Have you ever stopped to think about the fact that the most complex thing in the entire known universe is sitting right inside your own head? That's what we're doing today. We are taking a tour of that incredible, mysterious universe. Let's dive in.
I mean, you don't have to take my word for it. Just listen to Nobel laureate James Watson, who called the brain the last and grandest biological frontier. And he was not kidding. We're talking about an organ with somewhere around 86 billion neurons, each one capable of making thousands of connections. You do the math, that's more connections in your brain than there are stars in the Milky Way galaxy. It's just mind-boggling.
And this ridiculously complex network, it's responsible for every single thought, every feeling, every memory, and every action you've ever had. So the big question is, how on earth does this universe actually work? Well, to understand any universe, you've got to start small, right? You start with its most fundamental particles. And for our brain, that means we're going way down to the micro level to meet its master messenger.
Okay, so say hello to the neuron. This little guy is the basic building block of your entire nervous system. And remember that number, you've got about 86 billion of them firing away right now. Literally everything you see, hear, and feel starts right here, with these incredible little cells.
So how do they all talk to each other without it being total chaos? Well, it's actually a pretty elegant three-step dance. First, these branching bits called dendrites act like antennas. Their job is to receive messages. Then, the main cell body, which is called the soma, it processes all those incoming signals. And if the signal is strong enough, bam, it sends a new signal down that long fiber, the axon, to the next neuron in line.
But, there's a secret ingredient in this whole system, something that makes this communication incredibly fast. Any ideas what this little number might represent?
Yep, it's all about speed. It's called the myelin sheath. You can think of it like the rubber insulation on an electrical wire. It's this fatty layer that wraps around the axon and lets those signals travel up to 10 times faster. And here's where it gets really interesting. Our environment actually shapes this stuff. We know that things like social isolation in early childhood can get in the way of proper myelin growth, which can cause cognitive problems down the road. It's pretty powerful stuff.
All right, so we've got the wiring, and we've got the high-speed insulation. But what about the actual electricity, the signals themselves? Well, that brings us to the chemistry of our experience, and how it literally creates our inner world. We're talking about neurotransmitters, the brain's chemical messengers. Now, there are over 100 of them, but honestly, a handful of them do most of the heavy lifting. You've probably heard of some of the big players. You've got dopamine, that's our motivation and reward molecule. There's serotonin, which helps regulate mood. That's what many antidepressant meds focus on. And then you have GABA, which is basically the brain's natural chill-out signal. But here's the real key. It's all about balance. The best way to think about it is like a car. You have glutamate, that's the accelerator. It excites neurons, it helps you learn, it gets things going. But obviously, you can't have your foot slammed on the gas all the time. That's where GABA comes in. GABA is the brake. It calms things down, it reduces activity, and it prevents everything from going haywire. A healthy brain depends completely on this constant, delicate dance between go and stop. Okay, so we've covered the individual cells and the chemicals that make them fire. Now, let's zoom out. Let's look at the grand architecture of the brain, the actual physical structures that make you, well, you.
So that wrinkly outer layer of the brain, the cerebral cortex, is split into 4 main sections, or lobes. Up front, you've got the frontal lobe. That's the brain's CEO, in charge of planning, personality, impulse control. Then the parietal lobe. That's the sensor, processing things like touch and temperature. On the sides, the temporal lobe is the interpreter, handling hearing and language. And way at the back, the occipital lobe is the viewer. It's pretty much all dedicated to vision. But how do we know for sure that the frontal lobe is where our personality lives? Well, the answer comes from the really astonishing and frankly tragic case of a guy named Phineas Gage back in 1848. He was a railroad worker, and he survived this horrific accident where a huge iron rod shot right through his head, destroying a large chunk of his frontal lobe. Miraculously, he lived. But he wasn't the same person. He became impulsive, unreliable. His friends literally said he was no longer Gage. And his story, as sad as it is, gave us the first real hard evidence that who we are, our personality, it's physically located in the tissue of our brain. Okay, so that's the high-level stuff. But what about our deeper, more primal feelings, like fear and memory? For that, we have to travel deep inside the brain, to a set of structures called the limbic system. This is our emotional core.
Now, there are a couple of key players here you should know. There's the amygdala, you can think of that as your fear and aggression center. And then there's the hippocampus, which is like your brain's memory archivist, deciding what's worth keeping. And hey, if you ever need a way to remember that one, just picture a hippo walking around on a college campus. It's a pretty memorable image, right? And that's exactly what your hippocampus would be busy recording.
So far, it might sound like the brain is this fixed piece of hardware, right? Like you get what you get and that's it. But now we get to the most amazing, most hopeful part of this whole story. We get to talk about the brain's real superpower, plasticity.
Neuroplasticity is this absolutely incredible lifelong ability the brain has to literally reorganize and rewire itself by forming new connections between neurons. And look, this isn't just some fun science fact. This is the biological basis for all learning, for all growth, and for all healing. It's a total game changer.
And it basically works in two main ways. First, there's structural plasticity. That's when you learn something new, say a new language or how to play the guitar, and the brain's physical structure actually changes. Then you've got functional plasticity. This is when the brain cleverly reroutes functions from a part that's been damaged to a healthy area. It's exactly what's happening when someone recovers after a stroke.
And this is why it all matters so much. Plasticity is basically hope, but in biological form. It's how someone can learn to speak or walk again after a brain injury. It's the process that allows us to heal the invisible wounds of psychological trauma. And it's what happens every single time you learn a new skill. You are literally building a stronger, more connected brain.
So look at how far we've come. We went from a single tiny neuron to the complex chemistry of our emotions, to the grand architecture of our personality, and finally to the brain's incredible ability to change itself. So let's bring it all home and talk about what this really means for you.
If there is one single thing I want you to take away from all of this, it is this. You are not just a passenger of your own biology. You're not just along for the ride.
Your brain is constantly, every single second, being sculpted and reshaped by your experiences, by your actions, and by your choices. It is a living, dynamic system that you actually have the power to help shape. So I'm just going to leave you with this one question. Knowing that your brain can change, what will you choose to build?